will see what is that. Now there is one term is called notch sensitive, because we saw kf is equal to 1 and kf equal to kt. If kf of 1 is not sensitive to the notch, when kf equal to kt is sensitive to the notch. So one hand you have a kt, which is a static, theoretical or elastic stress concentrated factor. Other hand you have a kf, fatigue resistance. So how to connect it? There is a term to be connected here, because the way kt is readily available with Peterson or doing DFM, kf is not easily to be assessed, determined. So there something comes with the q, which is defined as kf minus 1 by kt equal minus 1. For shear stress, its formula remains same, only it is replaced with shear stress. Now kt is known, you can find out things. Okay, I will come there. So for notch-insensitive material, when kf is equal to 1, 1 minus 1 equal to 0, so q will become 0. And when kf is equal to kt, which is not sensitive, kt minus 1 by kt 1 is 1. So your q varies between 0 and 1. So also qs. For perfectly not sensitive material, kf is equal to kt and q is equal to 1. So that is something. So the fatigue stress constant factor is also expressed as. Now to get a kf value, this is what given, 1 plus kt minus 1 into q. Kt, of course, you can refer for a given geometry, you can find out kt. But again, how do you get a non-sensitivity q? Then again you have to refer some handbook. See, this is what is given, which is given by x-axis notch radius, which is an mm, also inch, and a q factor. Since steel has got a remarkable different ultimate strength, there are different curves are there, variation between q and notch radius with respect to ultimate strength of ferrous material, but for aluminum it's a single one. This for tensile, and for shear it is like this. So to get a q, if you know plate with circular hole or double notch or edge the single notch, you know the r radius, then in inch or mm, then you can find out the q. Once you know the q, once you know the kt, whether it's from DFM or in Peterson, then you can calculate the kf. Now to get a q, that curve has got this is a graphical form. Okay, if you want to do numerical to have a better thing, the Neuber has proposed this equation, q is equal to 1 by 1 plus square root, this is not p, is a rho r, and kf also expressed in terms of that, where r is the radius of the notch root and square root rho depends on the material. This is what graphical form is there, how the square root rho varies with the tensile strength of the material. A few will of square root rho aluminum. Please remember, this is for ferrous material. Though its variation tensile strength KSI, you cannot take aluminum whose ultimate strength falls below here. You should not take Q, because your mechanisms are different. Because as ferrous and non-ferrous, you will have a difference. For material aluminum, this is the equation. For steel, you have to refer this equation to find the square root characteristic this parameter. For aluminum, this is available. Now Peterson also given formula. A is the material characteristic length. This is given by for steel, or for aluminum it is constant 0.635 mm. So this is also given. If you know ferrous material ultimate strength, you substitute, find out the A. Once you find A, you can put A by R. You know the radius, what are the curvature, then you find out the Q. So the notch-sensitivity is not only a function of material properties, but also a function of the notch root radius that we saw there. Therefore, it incorporates the notch size effects into the analysis of a notch subject to fatigue loading. So what it says is, if you have a two plate of the same material, but geometries are 1/10 of that, okay, as a understanding you are taking 1/10, it can be different from that. For better understanding, you have a two plate, we will see what are the things. Plate 1, plate 2, width is 127 in plate 1, but plate 2 is diameter is 12.7. So second plate 1/10 at 1 point, but stress concentration factor remains same because dy w you are taking ratio. So for given dy w, Kt remains same. So Kt is 2.7, 2.7. But if you work and ultimate strength because the same material. The Q for the plate 1 is 0.97 and Q for plate 2 is 0.78. See, there's a difference. So your fatigue notch radiation factor for the plate 1 is 2.65, though it's a difference of hardly, what is it, 0.33, but that all makes a difference in life prediction. So finally, whatever qualitatively we saw some slide where smooth SN curve looks like that. As your increase in stress consider, it will come below